Good afternoon. My name is Aaron Morris. Hey, how's it going? I am the product manager for Recap in the Reality Solutions group. So I'm very excited to see all the presentations about the product later on from everyone else. I'm going to talk to you this morning more about reality computing or this afternoon I should say, about reality computing and the actual capture aspect of it, especially from drones. So before we get started off, kind of curious, polling the audience here, anybody know or have an idea what reality computing is? Shout it out. Anybody?
Capturing data.
Capturing data? All right. Anybody else?
Real-time meshing of the 3D elements we capture.
Okay. Anybody else have an idea? Take a stab at it?
Doing absolutely anything with data that is captured.
That's broad. All right. Well, let me try to answer it in from a few perspectives of examples I've seen out there. One example may be a life-size Jello mold of Nick Sable, his head. The story of how this came into existence. It starts with taking a photo, turning that into a digital representation, turning that into machine code, which mills it out, assembling that, turning that into a mold, adding a little bit of Jello, and getting a replica that was, again, taken from a photo. Other people might interpret it differently. The audio is not too loud here, but it's just a lot of screaming and some limited profanity, as this is a view from an early ride through the Google car. So if you look over, it came into the camera, we'll pan around, and you'll see the steering wheel is rolling on its own. Of course, on the roadways now, it's a little more controlled than it was before. But in this situation, what you're seeing is they have a version of reality. Everywhere the Google car drives has been mapped and detailed with its own sensors. So you see that the existing highway infrastructure is there. Everything's represented very well. And so when it's driving around, what it's doing is looking for objects that it wants to avoid, that it wants to interact with. But in this example, it's taking data, turning it into digital representation, and turning it into steering controls. For some other people, it may be about helping with a handicap. So this was a really interesting story. In fact, I just heard about this one last week. It started with a researcher interested in working with students to do 3D printing. And as the researchers working with them, they came across one of the students who had a disability. They had an impairment which sort of made it difficult for them to grasp pins. So right there on the spot, what they did, they had some clay. They held the clay, let them hold the clay in the most comfortable position that they could possibly do. They then took that clay mold of the grip, they scanned it, they digitized it, they brought it into a 3D modeler, and then they printed it. And voila, they had a 3D sort of haptic interface for a pen, or in this case, a stylus. For others, it's about doing things on a very large scale. So taking photographs from a helicopter of a city like San Francisco to create very beautiful 3D renderings, 3D representations. For others, it's taking this data and printing it and augmenting it so that you can visualize and tactily see new future skylines of what San Francisco will look like in the future. Yet again, for others, if you go down to a much smaller scale, it's about the ear, right? In these examples, you have custom hearing aids and devices where people take molds and they scan them and print them, so you can get an unlimited amount of custom, whether they're hearing aids or any hearing device that fits your ear. For others, it's about capturing artifacts. So this is the Smithsonian X3D viewer, in which they went around and digitized a large number of their, or several of their pieces, and made them available for anyone to manipulate, move around, and interact with. For others, it's about simulation. So, and not just simulation in a general sense, but in context to a particular environment. So there's an emergency, what could possibly go wrong here? Oops. So reality computing is a lot of things to a lot of people, as we've touched upon. And so at Autodesk, what we've been trying to do is sort of encapsulate all these ideas and concepts into one sort of cohesive idea so that we can start to communicate with one another and talk about sort of how to take digital representations or physical representations into the digital world and back into the physical realm. So for us, we like to say reality computing, it's about turning things into data, turning data into things, and then kind of what happens in between. Now, if that's a mouthful, we condense that to capture, compute, and create. So it's about digitizing, manipulating that digital form, and then bringing it back into the world. So we're going to have a lot of discussions, several discussions throughout the rest of the day, talking about things that you're doing with the data. So we're going to see about the things in the middle. We're going to see some of what happens at the end through construction or retrofit. I'm going to talk a little bit this morning about the capture aspect. Show of hands, how many people in here use laser scanning or at least familiar with it? All right, pretty good. What about photogrammetry, cameras, 3D reconstruction from cameras? Okay, about the same. So this will be quick since we have some people pretty knowledgeable. But you've got two different sensing paradigms. The camera to the opposite end of the spectrum, which is laser scanning. One is a passive sensor, so it requires energy from the sun or for illumination to illuminate the scene, and then you grab that to do your modeling. Whereas a laser scanning uses its own energy, right? So it's much more controlled. If you're paying attention to the world around you, there are devices popping up left and right. I think, who was it? Chad, you brought a new sensor, structured sensor. So there's all sorts of gaps being filled in from camera to sort of mixed camera and lighting conditions all the way up to the laser scanner. Real quickly, in a pure passive sense, this is called photo reconstruction, photogrammetry. Its basic principles is that you take a set of images around an object that has features. So these are both visual feature, textual feature. You do this pretty densely around the object, and from that, there are processes like Recap Photo, 123D Catch, that can recreate this object that you've imaged into a 3D model. I'll have a note from the people who use this, just a heads up, that usually the visibility matters. It's every 5 to 10 degrees around an object will get you a good result. Again, texture, I can't emphasize enough how important it is to get texture. You'll have a lot of people trying to image, a completely bland, uniform color, straight wall, or some object which it's very difficult for a camera from images to reconstruct. So the more visible features, the better. And also the object has to be fixed. It's not good to try to capture a moving object. So from that, again, you move the camera around, you encircle the object, and out comes 3D. Important note for those who are unfamiliar with this, 3D reconstruction creates a mesh, which is different from a laser scanner. Talk about that in a second, but a mesh is a connection. It's a surface around which the object is constructed. There's different representations that you can visualize. Most applications, definitely the ones in Autodesk, you can visualize each one. One is a wireframe showing the connectivity between points. Now there's just a plain surface that can be illuminated to show you the actual geometry. And then the final is a texture, which enhances that geometry, gives you really the effects and then also the color of the particular object. Moving from that toward the laser scanning, we get into sort of the mixed systems. These are what they call structured light. So there's something in projector that's broadcasting some sort of pattern, and that you've got cameras set up to record that pattern, and that creates 3D. So common devices, what you see out to do this today, some in non-visible spectrum, is things like the Kinect, which has been folded into cameras, the dot product, as well as Project Tango, which is Google's new 3D phone. On the